Welcome to the 47th lecture on quantum mechanics for semester 5 BSc Physics main students. Quantum mechanics 47th lecture problems part 2. We are now doing some important problems, and in the last lecture we have seen some problems, and problems we continue. Quantum mechanics 47th lecture. The first problem, it is a very important problem, a frequently asked problem. We look here. If the wave function for a system is an eigenfunction of the operator associated with the observable A, show that expectation A raised to n is equal to A expectation 4 raised to n. If the wave function for a system is an eigenfunction of the operator associated with the observable A. Operator under observable A under. Eigenfunction for a system is the wave function of for a system is an eigenfunction of an operator A. Operator associated with the observable A. So that A raised to n expectation is A expectation all raised to n. So we see, by definition of expectation value, we know A expectation is equal to integral. Here, capitalize the operator and capitalize also its eigenvalue. So expectation is equal to integral minus infinity plus infinity psi star A side dx. That is our definition. Therefore, A raised to n expectation, which is LHS, is integral psi star A raised to n psi dx. And this A raised to n in the RHS we write as A raised to n minus 1 into A. Therefore, RHS becomes integral psi star A raised to n minus 1 A psi dx. I think it is very easy. A raised to n is A raised to n minus 1 into A. Again, we repeat this step. Expectation A raised to n is equal to integral psi star A raised to n minus 1. Next is ASI, capital SI. Capital SI is small si. If the eigenvalue is small a, we can write psi star A raised to n minus 1 is ASI dx. In that manner, we can write. If A is an operator, its expectation value for the time being, we write as small a, ASI dx. And this small a is a constant value, we can take outside the integral sign. So expectation A raised to n is equal to A integral psi star A n minus 1 psi dx. Again, we split A raised to n minus 1 as A raised to n minus 2 into A, and we write A psi as small a psi. Small a psi is again taken out. So we get A square integral psi star A raised to n minus 2 psi dx. This will be proceed. Now we write A raised to n minus 2 as A raised to n minus 3 into A, and proceed in the same manner, similar manner, then finally we reach a step like this. What is the step? Expectation A raised to n is equal to A raised to n integral psi raised to psi star A raised to n minus A raised to n minus n. N minus 1, n minus 2, n minus 3, n minus n. When we take A raised to outside, n minus n psi dx. A raised to n minus n is A raised to 0, which is 1. So we get A raised to n into integral psi star psi dx. Integral psi star psi dx, that is the normalization condition. And that we write as 1. So integral A raised to expectation A raised to n is equal to A small a raised to n into 1. That is expectation A raised to n is equal to A raised to n equation number 1. That is a LHS. LHS, we have taken the LHS first and solved it to be equal to A raised to n. Now we take RHS. And we know A expectation is integral psi star A psi dx is equal to integral psi star A psi, you know, small a psi. We have taken for the time being the value as A psi, the eigenvalue equation. A psi dx. and a can be taken out. Small a can be taken out of the integral sign is equal to a into psi star psi dx. And integral psi star psi dx is 1. Normalization condition. So a into 1 is equal to a. Therefore, a expectation of 1 raised to n is equal to a raised to n. Equation number 2. What is equation number 1? Expectation a raised to n is small a raised to n. What is equation number 2? Expectation a whole raised to n is a raised to n. Since RHS of equation 1 and 2 are same, small a raised to n, we can equate LHS. Then we get expectation a raised to n is equal to a expectation whole raised to n. You study well. This is a very important question. Now we can see another question. The Hamilton operator of a system is H is equal to, this is one-dimensional system. One-dimensional system. H is equal to minus d square by d square plus x square. Show that nx e raised to minus x square by x square by 2 is an eigenfunction of n and determine the eigenvalue. Also evaluate the normalization constant of the function. അപ്പോൾ ഒരു ഓപ്പറേറ്റർ ഉണ്ട്, ഒരു ഐഗൻ ഫംഗ്ഷൻ ഉണ്ട്, അതിൻ്റെ ഐഗൻ വാല്യൂ കണ്ടുപിടിക്കാനാണ് ചോദ്യം. അതുപോലെ നോർമലൈസേഷൻ കോൺസ്റ്റന്റ് കണ്ടുപിടിക്കണം. അപ്പോൾ നമ്മൾ പഠിച്ച ഒരു ആൻസർ ഉണ്ടല്ലോ, ഇഫ് psi is an eigen function for the operator a, then we can write a psi is equal to small a psi, where small a is the eigen value. Given h, operator h, instead of capital A, operator h is minus d square by d square plus square, and function psi is equal to nx e raised to minus x square by 2. Function and operator are given, so we can write like this. You have to read carefully. Let us find h psi. H psi is equal to minus d square by d square plus x square. This is not the normal h. Here the potential function is taken as x square, not as v. Therefore, we get minus d square by d square plus square. Give the function nx e raised to minus x square by 2. And we separate it. You multiply inside. Is equal to minus d square by d square nx e raised to minus x square by 2 plus x square into nx e raised to minus x square by 2. And the first integral term, you look here, it's a second derivative. So we differentiate once. So outside we write d by dx. When we differentiate one, the second order differential becomes first order. I decided we have to differentiate. So minus d by dx, and inside we have to take the derivative of a product. So first function into derivative second plus second function into derivative first. How will you take first function? We take nx as first function and e raised to minus x square by 2 as second function. So first function into derivative second. Derivative of e raised to minus x square by 2 is e raised to minus x square by 2 into minus 1 by 2 into 2x. Plus second function derivative first. Second function is e raised to minus x square by 2 into first function is nx, n into 1 derivative. So once we have differentiated the second term, we write as such, no change. Again we write that is capital H psi is equal to minus d by dx inside the bracket x into x square. There is 2 and 2, 1 by 2 and 2 will cancel. We get minus, there is a minus sign, minus n square e raised to minus x square by 2 plus n is written first, n e raised to minus x square by 2, then the term outside the bracket plus x square nx e raised to minus x square by 2. Is equal to minus minus plus d by dx nx square e raised to minus x square by 2 minus d by dx nx n e raised to minus x square by 2 plus n square e raised to minus s square by 2. Now, the term in the bracket, first term in the bracket, we differentiate using product rule. First function into derivative second plus second function into derivative first. Here, the first function we have to take as nx square. Second function as e raised to minus s square by 2. Therefore, n square into e raised to minus s square by 2 into minus 2x by 2 plus second function e raised to minus s square by 2 into n into 2x. The last term, the second term. Second term is how we differentiate it. It has only one derivative. There is no product formula. Minus n e raised to minus s square by 2 into minus 2x by 2. The last term, we write as such without any change. And you simplify, the first term becomes minus nx cubed e raised to minus s square by 2. The second term becomes 2nx e raised to minus s square by 2, minus x square by 2. The third term is nx e raised to minus s square by 2, and the last term is nx cubed e raised to minus x square by 2. The first term and last term being minus and plus cancel. So the remaining is only like terms. One is 2nx e raised to minus s square by 2, other is nx e raised to minus s square by 2. The two terms are similar terms, so we can add them, we get 3. Which is 3nx e raised to minus s square by 2. And you know nx e raised to minus s square by 2 is psi. So HSI is 3 psi. So 3 is the eigenvalue of the above function for the given operator h. 3 is the eigenvalue. So that is explained in this paragraph. Thus, this equation is of the form ASI is small si. Therefore, here, therefore here, you look here. Therefore here, the operator etc. is cancelled. Here, psi is nx e raised to minus s square by 2 is an eigenfunction of the operator h is equal to minus d square by d square plus x square. The eigenvalue is 3. Now, what is remaining is to find the normalization condition. To find normalization condition, constant, we have to find the normalization constant. The normalization condition is, we write the condition, we know it. Integral psi star psi dx is 1. We write a function and its conjugate. Both are same because there is no I in the function. Integral minus infinity to plus infinity nx e raised to minus s square by 2 into nx e raised to minus s square by 2 dx is 1. Multiply n square integral x square, n square is taken out of the sign. N square integral x square e raised to minus s square by 2 minus s square by 2, we get minus s square dx. And that integral is a standard integral and its value is written here. It is equal to root 2 pi by 2. From the table of integrals, we can see that integral is root 2 pi by 2. It is put to there. N square into root 2 pi by 2 is 1. Therefore, n square is 2 by root 2 pi. N is 2 by root 2 pi raised to 1 by 2. N is 2 by root pi raised to 1 by 2. Therefore, the normalized wave function is psi is equal to n is 2 by root 2 pi raised to 1 by 2 x e raised to minus x square by 2. Next is another problem. Show that the commutator x, comma, commutator xh equal to minus h cut square by m. അപ്പോൾ ഈ ക്വസ്റ്റ്യൻ നോക്കുക, കമ്മ്യൂട്ടേറ്ററിനകത്ത് കമ്മ്യൂട്ടേറ്റർ വന്നിരിക്കുകയാണ്. എക്സ് എച്ച് കമ്മ്യൂട്ടേറ്റർ ആണ്. എച്ച് എന്ന് പറഞ്ഞാൽ ഹാമിൽട്ടോണിയൻ, നമ്മുടെ യൂഷ്വൽ ഹാമിൽട്ടോണിയൻ. കമ്മ്യൂട്ടേറ്ററിനകത്ത് കമ്മ്യൂട്ടേറ്റർ വന്നിരിക്കുകയാണ്. എങ്ങനെ നോക്കിക്കേ, ആ ബ്രാക്കറ്റിനകത്തെ ടൈം നോക്കിക്കേ, എക്സ് എച്ച് കമ്മ്യൂട്ടേറ്ററാണ്. അത് എക്സുമായിട്ട് ഒരു കമ്മ്യൂട്ടേറ്റർ ഫോം ചെയ്യുകയാണ്. അപ്പോൾ എങ്ങനെ വായിക്കും നമ്മൾ? കമ്മ്യൂട്ടേറ്റർ എക്സ്, കമ്മ്യൂട്ടേറ്റർ എക്സ് എച്ച്, അത് മൈനസ് എച്ച് കട്ട് സ്ക്വയർ ബൈ എം എന്ന് തെളിയിക്കണം. എം ആസ് പാർട്ടിക്കിളാണ്. അല്ല കമ്മ്യൂട്ടേറ്റർ ഒന്ന് വായിക്കാൻ നോക്കുക. കമ്മ്യൂട്ടേറ്റർ എക്സ്, കമ്മ്യൂട്ടേറ്റർ എക്സ് എച്ച്, എക്സ് കോമ കമ്മ്യൂട്ടേറ്റർ എക്സ് എച്ച് ഹോൾ കമ്മ്യൂട്ടേറ്റർ ഈസ് ഈക്വൽ ടു മൈനസ് എച്ച് കട്ട് സ്ക്വയർ ബൈ എം. പ്രൂവ് ഇറ്റ്. This we do in the next lecture, and if you are interested, you can try. You can try and find the value. The equation we use is a comma b commutator is ab minus b. Using that, we can find the value of this commutator, and h operator, you know, minus d square by d square h square. The h operator you take. I shall do in the next class. You can try. I shall do it in the next class. That is all with your 47th lecture on quantum mechanics. We continue in the next lecture. Thank you very much.